In question 5a, we need to differentiate a function which is expressed as a fraction. This requires the quotient rule. We let u be equal to the numerator, which is 1, and we let v be equal to the denominator, which is 5x squared plus 7. Differentiating u tells us that du dx is 0, and differentiating v tells us that dv dx is 10x. We sub these values into the quotient rule statement, and then simplify to get our final answer. In part B, we must evaluate the derivative of a function at pi over 2. The function is written as the product of two expressions, so here we should use a product rule. The first term, u, is tan of x over 2, and the second term, v, is ln of x. To find du dx, we must use a chain rule. The inner differentiation gives us 1 over 2, and the outer differentiation gives us secant squared of x over 2. Du dx is found by multiplying these together. dv dx can be obtained directly using a rule from the formula book. ln of x differentiates to 1 over x. Now that we know our derivatives, we can sub into the product rule statement. To evaluate the derivative at pi over 2, we replace each x with pi over 2. From here, we simplify our expression and do some calculator work. C involves functions. In part 1, we must apply f and then g to an input value of 3. F maps 3 to the icon of the world, and then g maps the icon of the world to w, so that's our answer. To solve part 2, we must show that g is injective but not surjective. A function is injective if no output value is mapped to more than once. For the function g, the output values correspond to the set C. Since no output value in C has more than one arrow coming in, g is injective. A function is surjective if every output value is mapped to at least once. Since y has no arrow coming into it, g is not surjective.